This lesson is intended to wrap up experimental and theoretical probability. We used the active votes in class, so it was a voting lesson. Amanda works at the produce department in Safeway. When she got a new shipment of oranges to put out, she found that some of them were already starting to rot. Out of the 300 oranges in one box of the shipment, 42 were rotten. She has one more box to put out. Based on the first box, what is the probability that she'll find some rotten oranges? So there's a fraction and a decimal blank. For the fraction, we voted on what are the possibilities: 1 out of 42, 42 out of 100, 42 out of 300, or 14 out of 100. And there were two correct answers. It's 42 out of 300 oranges, because that's what she saw in the first box. But that also simplifies. Divide by 3, and you get 14 out of 100. And I do that to help them with the decimal, which is the next question. What's the decimal? Is it 42 hundredths, 14 hundredths, 42, or 3/10? Well, it's 14 hundredths, because 42 300ths can't be the same as 14 hundredths. You have to simplify it down to hundredths in order to get that. So B is the correct answer here, 14 hundredths. Or you can also do 42 divided by 300 to get the decimal, and you get 14 hundredths. And then the last question, is this theoretical or experimental probability? Well, it's based on something that actually happened. She actually counted the other box out and found how many were rotten, so it's experimental. It's a prediction based on what already happened. So we're reviewing the difference between finding experimental and theoretical probability, and the kids had an exit card this day. So I'm going to buzz through these pretty quickly. This is based on some stations that we did in class last time, the class before this. So the idea here is I rolled this 20-sided die 100 times. I kept track of how many times I rolled each number and recorded them in the table below. What is the theoretical probability of rolling a 4? Well, I don't even need this information for that yet, because it's theoretical. It's about possibilities. So it's a 20-sided die. So that means, and I want to know the probability of rolling a 4. So that's one possibility out of 20. So B, 1 out of 20. The decimal for 1 out of 20 is the same as 5 hundredths, because 1 divided by 20 is 5 hundredths, or 20 times 5 is 100, and 1 times 5 is 5 hundredths. 5 hundredths. Then we look at experimental probability. This is where the table comes in handy. I rolled it 100 times. My denominator is going to be 100, because that's how many trials there were in my experiment. I'm looking for the 4. How many times did I roll it? I rolled it 5 times. So, 5 out of 100. And 5 out of 100 is actually the same as 120, because I simplify. And then again, 5 hundredths. Bam. The probability of rolling a 7 or an 8. So theoretical, we're looking for theoretical. So that's 2 options out of 20. 2 out of 20, which simplifies to being 1/10. Divide by 2. Theoretical probability, this as a decimal, 1/10 is the same as 10 hundredths. Experimental probability of rolling a 7 or an 8, so that's these two. It's 100 total rolls, so that's my denominator, and 11 of them were either a 7 or an 8. So 11 out of 100, which goes into a decimal really easily, 11 hundredths. Just as a reminder of how you get theoretical fractions and how you get experimental fractions. Theoretical is the number of possible ways to get an event out of the total number of possible ways to get any outcome. Experimental is the number of times an event resulted out of the total number of trials in the experiment. I'm going to skip past these. At least I'm not going to explain them, I'll just give you the answer. So, theoretical probability of each outcome, 1/10. As a decimal, 1/10 is the same as 10/100. Theoretical probability of rolling an even number on a 12-sided die is 1/2. Or 6 out of 12, those are the same thing. As a decimal, that's 5/10. Experimental, rolling an even number. 19, 26, 35, 43, 53, 53 out of 100, which is the same as 53/100. These are the theoretical probabilities for a deck of cards. They're just already filled in. There's one Queen of Hearts in deck, and there's 52 cards, so 1 out of 52, and so on. And then this is our review for our exit card. Lisa and Seth tossed a coin 100 times. The coin landed on heads 52 times and landed on tails 48 times. According to the experiment, what is the probability of landing on heads? This is very important. It's according to the experiment. So even though normally it's 1/2, we want the experiment's probability. So it's 100 times, so 100 on the bottom. Heads 52 times, so 52 is the numerator. 52 out of 100 is the same as 52/100. Jessica conducted a survey of 15 of her friends to find out which movie genre they liked best. 6 said horror, 5 said science fiction, and 4 said drama. According to the survey, what is the probability a friend would choose horror or drama? So that's 2 options, horror or drama, 6 and 4. So that's 6 and 4 makes 10 out of the 15 total people. 10 out of 15 divided by 5 is the same as 2/3. Didn't need to do that, but that's what it would be simplified. A 6-sided number cube is tossed. What is the probability of landing on an odd number? Half. Half of on a normal 6-sided number cube. It's numbered 1 through 6, so you get 2, 4, and 6. Okay, Lisa put the following Skittles in the bag: 14 red, 10 orange, 8 yellow, 12 green, and 6 purple. She pulls one out at random. What is the denominator of any probability fraction for this experiment? Before simplifying, you add them together. 14 plus 10 plus 8 plus 12 plus 6 is 50. So knowing that 50 is the denominator, Lisa put the following Skittles in a bag: 14 red, 10 orange, 8 yellow, 12 green, and 6 purple. What is the probability of selecting orange? Well, let's see. 10 orange out of 50 is the same as 1/5. 10 out of 5, 1/5. Yellow or green? 8 yellow, 12 green. 8 and 12 makes 20. 20 out of 50 is the same as 4/10. And if that doesn't make sense, divide by 5. 20 divided by 5 is 4, and 50 divided by 5 is 10, 4/10. What's the probability of getting candy? Well, they're all candy, so 1. What is the probability of getting pink? Well, there are no pink, so 0. And what is the probability of not getting orange? There are 10 orange, that means that 40 are not orange. 50 minus 10 is 40. 40 out of 50 is the same as 8/10. Again, I could divide by 5 to get that, or I could just do 40 divided by 50 equals 0.8. Okay, a survey was taken of 20 people to see where people do most of their grocery shopping, and the results are listed below. So this is 20 people. What is the probability a person will shop at Giant? So it's going to be out of 20. 1, 2, 3, 4, 5, 6, 7 people out of 20 shop at Giant. I could divide 7 divided by 20. I could multiply by 5 to get hundredths. And I get 35 hundredths. C. Same, what is the probability that a person will shop at Bloom or Safeway? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 out of 20 is half. Either of these are fine. And that is the review for theoretical and experimental probability, and we had an exit card for that.